Unit 3, Boolean expressions and if statements. Topic 3.5, Compound Boolean expressions. Nested if statements consist of if statements within if statements. This example uses nested conditional statements. Look at how your computer will process these statements. If the first Boolean expression evaluates to true, your computer will then check the nested if statement condition. If the nested statement evaluates to true, the code within that statement will be executed. In other words, both Boolean expressions must evaluate to true in order for this code to run. If the nested Boolean expression evaluates to false, your computer will not execute the code and will exit the if statements. Spacing and indentation will be of utmost importance for making your code readable. In this example, we initialized a variable called number of type integer to store the value 36. You might notice the nested if statement. Trace the code to see what this program will display. Trace the code when number stores 40 to see what the program will display. Trace the code when number stores 6 to see what the program will display. Here's one more example. Trace this code to see what the program will display. How can we create larger and more complex Boolean expressions? Using logical or Boolean operators. Logical operators allow programs to make decisions based on multiple conditions. This is the not operator. This is the and operator. This is the or operator. Logical operators not, and, or are used with Boolean values. This represents the order these operators will be evaluated. An expression involving logical operators evaluates to a Boolean value, true or false. To best visualize and analyze how logical operators work within Boolean expressions, we will use truth tables. The not operator evaluates a condition to the opposite Boolean value. In this example, if x is equal to true, not x is equal to false, and so on. When using the and operator, both Boolean expressions must evaluate to true in order for the compound expression to evaluate to true. When one is false, the whole compound expression will evaluate to false. When using the or operator, at least one Boolean expression must evaluate to true in order for the compound expression to evaluate to true. When the result of a logical expression using and or can be determined by evaluating only the first Boolean operand, the second is not evaluated. This is known as short-circuited evaluation. In the case of x and y, which of these might be considered a short-circuited evaluation? If you guessed either of the last two rows, you are correct. Because the first expression evaluates to false, the compound expression will evaluate to false regardless if the second condition is true. In the case of x or y, which of these might be considered a short-circuited evaluation? If you guessed either of the first two rows, you are correct. Because the first expression evaluates to true, the compound expression will evaluate to true regardless if the second condition is false. Logical or Boolean operators have an order of precedence. Not takes precedence over and, which takes precedence over or. Let's observe some examples. It's easier to see if we replace the letters with their Boolean values. Not false evaluates to true. True and false evaluates to false. Just as not takes precedence over and takes precedence over or. We will always evaluate and before or. We can put parentheses around the expression to indicate how this will be evaluated. Let's take a look with Boolean values. True and false evaluates to false. False or false evaluates to false. Let's try a practice problem. What's the correct evaluation of this Boolean expression? Start by putting parentheses to help identify order of precedence. In this case, wrap values with not and the two values in an and. Now let's evaluate the not expressions. Then the ands. The final result then is true, as only one value needs to be true in an or to be true.